What's up guys, it's Rob from BreVITy, and in this video we're going to look at an amazing application of the two-pointer algorithms called a Dutch flag partitioning algorithm on a LeetCode problem called sort colors. Let's check it out. In the previous video, I explained the algorithm in great detail. What? You haven't seen that video yet? You know it's perfect, right? I highly recommend you to go watch that video first to get a good grasp of what we're going to code over here. Here's a rapid recollection. Consider this a visual representation of the array from 0 to n-1. We'll be using 3 pointers: start, cur, and end. Cur is more of an iteration variable, so the 2 extra pointers which we are going to be declaring here are the start and the end pointers. Now the start pointer will be initially pointing to 0 and the end pointer will initially be pointing to n-1. The red section from 0 will contain all the zeros. The white section will contain all the ones. The grey section will contain all the elements which are unvisited and unsorted. And the blue section will contain all the 2's, and it starts from end all the way to n-1. So as cur moves from 0 to n-1, depending on whether it encounters a 0, a 1 or a 2, it will be put in one of the other 3 sections until the grey portion disappears and becomes 0. This is a very basic gist of the algorithm. For a more detailed algorithm, check out the video which I shot earlier for this problem. I'll put the link down in the description below. Step 1. Implement the algorithm. Now the first step in the algorithm was to initialize the pointers. So we have 3 pointers: int start equals 0, int cur which is also pointing to 0, and int end which is pointing to the last index in the array, which is nums.length -1. And while cur is less than or equal to end, we're going to keep checking what balls we encounter while using the cur variable. Now the first condition that we might encounter is if we find a red ball. And over here we can see that the integers 0, 1 and 2 are going to represent the color red, white and blue respectively. So if nums of cur equal to 0, we have found a red ball. So in this case, we are going to swap the balls which are present in the start index and in the cur index. So in order to swap elements, we'll use the temp variable. So int temp equals nums of cur, then nums of cur equals nums of start, and nums of start equals temp. And then we are going to have to increment the cur pointer and the start pointer. So cur ++ and start ++. So that is the first case. Else, if nums of cur is going to be a white ball, in this case we are simply going to increment cur. The white ball is already present in the right place, so no swapping will take place in this case. So we are simply going to do cur ++. The final case is if we encounter a blue ball, that is if nums of cur equal to 2. In this case, we are going to again have to do a swap. So in this case, we are going to swap the start pointer and in this case, we'll be swapping the cur pointer and the end pointer. So int temp equals nums of cur. Nums of cur is equal to nums of end, and nums of end equal to temp. And now we are not going to increment the cur pointer. If you don't know why, I highly recommend you to check out the other video I was talking about. We are only going to decrement the end pointer. So end minus. And that's about it. So let's run the code and see if we get any compilation errors. Okay, we can see that the sample test case passed. So now let's move on to step 2, which is testing for edge cases. Now One of the edge cases we can think about is what if we get an empty array as the input. So if we get an empty array as input, then start will point to 0 and end will point to -1. So since cur is 0 and end is -1, 0 less than or equal to -1 is false. So this the while loop will not even run. And if there are no elements, then it's already sorted. So that condition is taken care of by our program. What if the array contains only one element? In that case, cur will point to 0 and end will also point to 0. So 0 is less than or equal to 0. So we'll go inside the while loop. And then we'll have any one of the balls. So we'll have either a red ball, a blue ball, or a white ball. So if it's one of the red or the blue balls, then we're simply going to swap the same ball in the same place. So it's not going to make a difference. So if we look at it, even that edge case is satisfied. So we can say that all the edge cases are satisfied for our program and we don't need to specifically implement them. So let's move on to step 3, which is the debugging phase. And here we don't have to do it because I already know what I'm doing. But if we did not get the answer, then we would have been going into the debugging phase, which won't be there for this week. Now let's go to step 4, optimization. Now, when I look at this program, I can see that I'm using an increment operation after a swap operation. And one thing which Java lets us do is to use something called post increment, which means over here, instead of saying cur++, I can simply put cur++ over here itself and delete the statement altogether. Now, what does it mean? First, nums of cur will become nums of start. So this swapping will take place. And after the swapping takes place, the cur pointer is going to be incremented. This is called a post increment. The same way we can also do that for start++ as well. So we just reduce 2 lines of code. Now we can do the same thing for this case as well for n minus minus. So we can simply put n minus minus over here and remove this line of code as well. Easy, right? Now another thing we can do is, we know that nums of cur is always 0. So why do we have to initialize a temp variable which is always going to be 0? So in this case, we can just delete this line and directly say that nums of start++ equals 0. Right? It's the same thing. The same way we can remove this variable as well and say nums of n minus minus is equal to 2. Right? So let's try running the code again. And we can see that the code is still functional. Let me submit the program and check for the time and space complexity. Step 5, the time and space complexity. Now in this case, this time complexity is going to be O of n. This is because we traverse to the entire array only once in the worst case scenario. This usually occurs if the array contains balls which are all of the same color. Now if we are talking about the space complexity, it is simply going to be O of 1. That is because we are only declaring 3 pointers, start, cur and end, which will occupy constant space in memory. And that's it for this video. Thanks for watching. If you enjoyed this video, do like, comment and share with your friends. Also, if you haven't subscribed yet, do hit that subscribe button to be notified of our new videos. On that note, this was Rob. You're watching BreVITy. Thank you and goodbye.